Is it okay?
Yes, you can start.
Hello, everyone, for a new webinar in this series of webinars from Learning from the Extremes project. I'm very happy to introduce today's webinar, which will explore the world of 3D printing. After a short introduction about 3D printing and how we can use it in the classroom, the tool Tinkercad will be presented. In order for you to have ideas about how we can create models in a simple 3D object. And I couldn't introduce a more fitting person to do this webinar than my dear colleague and friend Priscilla Doran from Núcleo in Portugal, who is an expert in this issue and to whom I gladly give the floor. Priscilla. The floor is yours.
Thank you, Jesus. Thank you. Hi, everyone. This is the second time I'm doing a webinar, so I'm hoping that many of you watching already know my face. Just so this can be a little bit more interactive, even if we have a lag between what I say and what you respond, I would really like for those who are watching to just write something on the chat, leave a comment, say where you are from, so that we have at least some kind of interaction. Also, I will share my screen where you can see my email. Let me try it now. Can you see my presentation?
Yes.
Yes?
Perfect.
So you have my email here. So if you have any doubts, if you want to share something or you need any support, feel free to contact me or any of my other colleagues in Núcleo. So today I was called to talk about 3D modeling and printing. I am far from being an expert in these maker competencies, but I think that just knowing a little bit, we can do a lot. And my goal here is just to give you some lights, some hints, so that you can also start exploring and also teaching just a little bit to your students, and you will see that they will learn so much more than we expect. So what is 3D printing? I'm going to give you just a small introduction. Do you see my cursor on the screen moving? Gustavo?
Yes, we do, Priscilla, we do.
You do? Okay, thank you.
Yeah, sorry, I was muted. Yes.
3D modeling, or better saying, 3D printing starts with modeling. And as you can see, we have here people from all ages. We do have kids that you cannot see on the other side of the picture, just learning how to model a simple cannon. So it starts with modeling, which I will show you today. And then we go to the printing part. Printing in 3D can have many shapes, many forms. You have many different types of 3D printers. You can have resin ones, you can have filament ones. I'm going to talk to you about the ones that use filaments. And even inside the world of filament printing, you have so many different types of filaments and so many different types of printers that it would be impossible for me in 1 hour to talk to you about everything. But the ones you are probably acquiring for your schools and working with students function as the ones you are seeing in this picture. The one on the middle of the screen is one of our printers, and this is just a design of a printer. So the way it goes is you have the filaments. So your object will be the color of the filament that you choose, independent of the colors you see in your modeling. So the filament is attached to the printer, and then it goes inside this mechanism. And here it gets heated, so it melts, it becomes liquid, and the liquid is deposited in slices that then form the object that you have modeled. So this is basically it. You make a design, you send it to the printer, and the printer prints it for you. I'm trying to move my slide forward. Okay. So 3D printing has many applications in the world. It is used by companies and by entrepreneurs to do prototyping. For example, you see here some shoes. Instead of going to a manufacturer and wasting a lot of materials and a lot of money, you can do your own initial prototypes so that then you can design your final product. It is used in medicine for prosthetics, orthodontics, personalized medications, and much more. It is used in construction. Believe it or not, you have already houses and boats and big constructions built in 3D, obviously with different 3D printers than the ones that we have, but it is really amazing. And these are all pictures that I found online, so you can just do a little search online and you will find this anyway. And then we have the world of education, which is the one we are talking about today. And these images show just some little ideas about 3D printing. So here on the left, for example, you see a project about windmills and sustainable energies. And the students design their own mills. I think this is the word in English, I'm not sure. Here you have this is a meteorological station, or at least it measures the temperature and the humidity of the air. And in order to be protected, a little case was designed in 3D. Here we have a prototype of nuclear energy, and again, the mill was produced in 3D. But it can also be used for many other purposes, like, for example, building DNA prototypes so that students can learn in a more hands-on way. You can build surfaces, tactile surfaces for people that are visually impaired. You can design models of the solar system. And, you know, these are just a few ideas. Here you can see the printer printing. For example, we designed a solar car, and some of the pieces were missing, so why not design them ourselves and use our printers to solve problems? This is what the students did. This is what your students can do. They can design their own little pieces, little objects. I'm listening to a lot of noise in my background. If you also listen, tell me that I can try to put some headphones, okay? And this is for Nikos, Rosa, Gustavo.
It's okay.
If you have
That's
trouble
fine for
listening.
me.
So now I will get out of my presentation and I will go directly to my browser, and I'm going to show you one of many possibilities that you can use to create your 3D models before sending them to the printing. My colleague David from Nucleo did the last webinar, I think last week, and he made a really good presentation of this tool. So you can use Tinkercad to do many things. You can do 3D modeling. You can simulate circuits and learn about electrical circuits and programming, microcontrollers, a lot of things. And then you can also play with code blocks. But today we will work on the 3D design part. So the first step, as David showed also, and you can watch his video to learn, is to sign up. I'm going directly to log in. I will log in as an educator with Google. Is the easiest way for me, at least. Okay, and now you can see I already have 2 classes as an educator, and I'm going to show you how it looks inside. You can see your students. They can either log in with an account or with just a join code for the classroom. You can see all the designs that they have made. So they have made some super cute designs. And you can also give them challenges, activities, and tell them to do specific designs, or you can just leave them to do whatever designs they want. And then here on the left side, I can see tutorials that I have already made, that I have found and finished. I can see challenges if I have some, I don't. And I can see my designs. So here I will see all the designs that I have made through this account. So you can see some keychains, some spoon holder, so different designs. And I can tell you this is like a game. Once you start, and if you have time, it's very difficult to stop. So I will create a new one. I want to create a 3D design. and I will see my work plane. We have to consider this work plane as if it was the basis of our 3D printer, okay? And you can see the scale of your grid. You can zoom in, and you'll see that each of these is a millimeter, so each big square is 1 centimeter. You can zoom out. With the right side of the mouse, you can see from different perspectives and different angles. And if you click on the little wheel, I don't know how this is called in English, of your mouse also, you can move it around like this without changing the angle. One thing that is very important is that when 3D modeling, it is very useful to have one of these things instead of using the one integrated in your computer. It makes it much easier to do the designs. So here you can also shift the perspective from top, from the front, from the right, from the bottom, and it's a more straightforward approach. But if you want to see from different angles, then you can use right side of your mouse. On the right side, you have basic shapes that you can use to do your models. And if you click here, you will see many different things that are already created. You can see little creatures, robots, and then you just drag them into your work plane. And you can change their size. You can manipulate them in any way you want. You can delete. So I'm going to go to the basic shape. And what I'm going to do is just a basic keychain that you can do yourself or with your students. I'm not going to do something complex because if you want, you have millions of videos on YouTube, okay, for all the types of designs that you want, from the most simple to the most challenging. So a keychain is a very good way to understand how this works. So I will start with the basis of my keychain. I will drag a cube to my work plane. And now I can see from all angles. If I click on it, I can see little white squares, and they will tell me the dimensions of my cube. If I want a 2 centimeter, not a 2 centimeter, it's too small, maybe a 4 centimeter, so 40 millimeters by 2 centimeters, I think it's okay. And then I want it to be 0.5 centimeter tall, so 5 millimeters. Okay, I think this is a good size for a keychain. And now I can play with the radius, so I can make it more round. I, for example, do not like it to be pointy, so I will make it just a little bit rounded. And you can also change the length, width, and everything here, okay? I just prefer to do it the other way around. Also, everything that I'm going to show you here, you have a million ways of doing them, okay? This is just the way that I personally do. You will maybe find different ways of doing the same things. So now, what am I missing to create a keychain? I'm missing a little hole for my keys, right? So I will drag, for example, this shape. See it from this angle, and I want it to be 5 millimeter diameter. So I've changed one of the dimensions, and now I will change the other one, and I will position it where I want it. In order to have a hole, I cannot have a solid figure. So if I come back here, I can either say that it is a solid, and I can choose a color, which is not important because the color of my keychain will be the color of the filament that I choose. Or I can say it is a hole. And in this case, I want it to be a hole. Now, to make it really a hole, I needed to go all the way through my keychain, right? And the way that I do it is through this little triangle here. I can pull it upwards and I can pull it down. And now I can see that it goes all the way through. So if I group the items, I will click and drag my cursor. And here I will group the items. It takes a little bit, and now I have my final version. You see, there's a little hole there. Okay, so now I want to make it more pretty. I can either make a drawing by clicking on Scribble, dragging it here. It will open a different work plane where I can make whatever I want. For example, I can try to make a little star, and you can make fun of my star. It's okay. I don't mind. Okay, and then done. I will make it shorter and smaller. If I don't want to lose the proportions, I will click on Control. And when I make it smaller or bigger, no, not Control, Shift. Sorry, you can click on Shift. So when I make it bigger or smaller, it will keep the same proportions. And now I lost my other design, so I will click on F. Not F. F is to center it. I'm sorry. I will just zoom out and I will drag it. Now I want to put it on top of my keychain, right? I have two ways of doing it. One of the ways is to drag it upward and then to the side. And I have to do it by eye, you see? So there is some margin of error. What I can also do, instead of this, I'll just make Ctrl Z, Ctrl Z, Ctrl Z and go back. I can come here and bring a second work plane to the top of my keychain. I'll bring this upward now, drag a second work plane to the top of my keychain. I will position the star where I want, and if I click on the letter D, it will immediately go to the work plane. And this way, I am sure that they are touching each other, which is important for 3D printing, as I will show you later on. Now that I did this, I will also write maybe my name. So I will drag text. I can write here whatever I want. So my name is Priscilla. And I will use the little squares to make it the size that I want. So maybe 25. Let me see if it's good. Oops, disappeared. 25 there and 10 here. Okay, I like it, but now it is also very tall, so I can make it a little bit shorter. And I can also change my work plane now back to where it was. And I have two options. I can either make my name as a whole, so I just push it inside and I make it a whole. And now if I group everything, you will see what it looks like. It failed for some reason. Try again. Okay, so it will be like a hole in my keychain, or I can make it as an elevation. And for that, I will ungroup everything again. I will make it solid and push it a little bit upwards. Okay, now I will just have to look from below to make sure that something is not happening. I'm going to show you what I don't want to happen. I don't want the letters to go all the way to the other side. So this is why we always should look from the bottom also. So I want it to come a little bit upwards. And okay, now if I click Ctrl A, I will select everything. I will group everything. Just wait a little bit. Sometimes this takes a little bit of time. And now I have my keychain. If I want to put other shapes, I can go to creatures, I can put an eye, I can give it a little mustache. You know, creativity has no limits. So now that my kitchen is done, I will export it as an STL file. And this is the file that goes to all the programs that work with 3D printers, okay? It's the STL. I will give it a name. I will put it on my desktop. Okay. So now, before I show you how to print, I'm going to talk to you a little bit more about 3D printing and things that we should be careful about. Here is a website called PrintLab. They have lots of nice resources and libraries and guides. And one of the nice resources that they have are these videos where they tell you about some things that you should consider when you are doing 3D printing. So the first thing is what they call overhangs, or in a more simple way of speaking, the angles on which you make your designs. And all of these things are things that you can test whenever you have a new machine or you are using a new filament. So they will show that different angles will create maybe bad or good printings. They are creating the objects to test the printer with different angles. So they go from straight to 90 degrees. And then they send this to the printer. And as you see, when you have an angle of 90 degrees, this is just printing on air and you get spaghetti, as we say. It is not effective at all. And then when you change the angle, you see that the quality starts increasing. So 90 degrees is not good. Usually from 45 degrees and less, you have good printings. And this is something to consider when you are creating your own designs or when you are starting to print. For example, here, they consider some of these will be good printings and some others won't because of the angle, so they are changing the angle. And now with this angle, it will be okay. The same thing happens when we build bridges because of the 90-degree angle that we have here. Oops, what happened? No, okay. So you see we have different bridges. This is a big one, a medium one, and a small one. They are just showing you how they made this design. And then they will try to print this design to test the printer. And the final result is that the small one did kind of okay, the medium one, not so good, and then the other one is completely spoiled. And this is important when you're making designs that use this kind of bridges. You can obviously solve this with supports that are created automatically by the printing programs, and which I will show you in a bit. Okay, another thing is the wall thickness. This one, I have fallen into this trap, and I have made some horrible designs because I forgot about this. You have here a design that they are doing with walls of different thicknesses. They start at 0.1 millimeters and they go until 0.8. And again, this is done to test the printer. So I advise you, if you have a new printer, to do all of these tests before starting to do your own models. Now they will print. As you see, the first 3 ones didn't even print. So it starts printing on 0.4 millimeters of thickness. Before that, the nozzle is too big. The nozzle is the place where the filament gets out of the printer. It is too big, so it doesn't work. Okay, now when we were talking about the angle and the fact that the angles were 90 degrees, so it spoiled the model, we can also have another way of doing it, which is changing the orientation of the printing. So if we don't have it standing, but we make it lie down, it will print perfectly fine. So here, we don't have anything hanging. So everything will be well printed. So sometimes your models are well done, The only thing is that you made them print in the wrong position. Here, no matter the angle, everything is okay. You see the difference? The one that was standing and the one that was lying down. Okay. Now we can talk about tolerance. This is very important when you want to create two pieces and one fits on the other. Even if you create them with the same size, it is possible that they will not fit because there is a tolerance that we should consider. And this is a really good test that you can do to see how tolerant you should be with your designs using a specific printer. So here they are showing us how they make the designs. They are creating one that is exactly the size of the hole, and then they are decreasing the size. And when it's done, they send it to the printer. And in the end, they could only fit the 3 smaller ones. And the first 3 ones, despite the fact that they are the same size, they did not fit. So as they say, there's a tolerance of 0.3 millimeters usually. And this is important, as you see, this is just an example. If you want to create a vehicle and you want a mechanism to fit inside it, you have to consider this. Now this is what I showed you. Sometimes if you have text, you can either put it as I don't know the word in English again, but in height, or you can make it as a whole. And sometimes if the text is really small, it will be much better to have it coming out of your object than to make it as a whole. And this is what they show in this video. They are just creating the object with the text. They're making one as a whole and the other as a solid. And then they are printing it. And in the end, we can see the difference. They are the same size. So the one as a whole didn't show up as well as the one that goes out of the object. This is just another application of how this may be important. Small hieroglyphs that are embossed in an object, they would look better coming outside than inside. Okay, another important thing is that if you have an object which the base is very small, when it is printing, it might fall or it might not adhere so well to the bases. So they are designing the same object. One is very pointy and the other not so much, and then they will print them. So it starts okay, but at some point it starts becoming wobbly. So again, one of the options will be to turn it upside down, right? To start printing the big part and then the small. Or as they show it, if you can, make it less pointy on the bottom. It isn't wobbly at all this way. So here they show the application as a real example. You can have a thicker basis and then it won't be a problem. Talking about these upward structures, here they are just trying to say that if you have a 90-degree, it might break. But if you create an angle, it is much more resistant. So they are showing here how to create the angle, and then they will print both. And by the way, I'm just going fast forward in these videos because they are on the internet. You can come to their website and watch them much more carefully. So now you have the two designs, and they will show that this one breaks very easily, while the other one is much more resistant. Okay, Gustavo, Rosa, Nikos, no questions, no comments, any interaction so far?
Now we have here Ana Vilar saying she finds it very interesting, and Jofer say he's loving it. But everyone, if you have questions, comments to Priscilla, please put on the chat, and we'll relay the questions to Priscilla. But for the moment, I think you can continue.
Okay, thank you. So now let's talk about sharp points. What they explain here is that when you have a very sharp pointy place, it becomes so hot that it kind of melts and you cannot have a very precise object. As they are modeling it now, then they will test it. And they will show what happens. As you see, it's very inconsistent. It's not good. So as always, there is a solution for this. And one solution is to print two of these objects so that the printer goes from one to the other. And while it does that, it gives it time to cool down a little bit. And then it will become much more perfect. So you see the difference. If we want to make Christmas hats, now it's the time to consider this. Okay. And now the last thing that they ask us is, respect your printer's limitations. Don't ask it to do things that it can't, because then you will have very bad printed objects. And here is just showing how they are exaggerating on what they are asking from the printer. And it's becoming filled of little spaghetti inside because this was just too demanding. Okay, so I'm gonna expect, I turned off my sound, I'm gonna turn it back on. So if there is some question, any comments, please make them now. There is a bit of a lag, but you can interrupt me anytime and make all the questions that you want. These are things important to consider. One of the main things that we see students and even teachers doing is this. Sending something to print like this. And you see, this is not touching the ground. And many times we have, can you guess? Spaghetti. Because there's nothing to support the printing. So it is very easy. On Tinkercad, if you want it to touch the ground, just select it and click on D, and it touches the ground. And always make sure that everything is okay. Sometimes I'm just going to make a little example of what happens. I bring a little triangle or a pyramid here, and it looks like it is where I want it to be. You see, from here, I think it's on the right. It's okay. And then if I change perspective, I will see that it was actually flying way, way, way far away. So just make sure that everything is on the ground, everything is touching, that you have the right angles, okay? And that everything is grouped together. So now that we know how to test the limitations of our printers, that all printers are different, they have different limitations. We know how to do a simple model. We know how to export to STL. And then we have to use a program that converts our STL file into a file that the printers will know how to print. The one that I use and many people use is called Ultimaker Cura. I will bring it down just because I'm sharing the screen and I cannot see everything. Sorry, just a second. Ah, it's so hard. Okay, I found it. So as you can see, this is already prepared as if it was my printer. I can find here many printers. So if I go to add printer, I can either say that I'm using a printer from the Ultimaker brand, or if not, I will go to the other printers. If it is connected to the network, it will appear here. If not, I will click on add a non-networked printer, and you see dozens, maybe hundreds of 3D printers here. You have all the brands, and then each brand has different printers. Oops, my computer is freezing.
Priscilla,
Yes, I'm here.
meanwhile, there's a question on the chat by Gilfer asking if it's possible to print an object with different colors. For example, a red mug with a blue handle. Is it possible?
For example,
A red mug with a blue handle.
yes, yes. It is possible if you have a printer with just one filament at a time. You can print layers. So you print the first layer with one filament, you change the filaments, and then you print the second part with another color. But you also have printers that already print with more than one filament at a time. So of course, if you only have one filament, you have limitations. You have to choose the right position, use the supports, so that you can make something with the two colors in a two-step approach. I'm going to repeat here just because my Ultimaker Cura froze for some reason. So I'm going to add the right printer that I'm using. It is a non-Ultimaker, non-networked. I can choose here. If I don't find my printer here, I can also go to custom FFF printer, which means that is using a filament. I will add it, and then it will ask me to say all of the configurations of the printer. And usually there is a file that comes with the printer that gives us all of these answers. We don't have to know them by heart. And then next, and I have my printer created. So what it does is that it will know already the temperatures and the size of the extruder and the size of my work plane. This is it is simulating to be my printer. I will bring my object now. I can either drag it to there or find it in my computer. And here I have my keychain. Now that my keychain is here, I can click on it and I will have several options. I can move it. I can select where I want it to be in the X, Y, and Z axis, or I can just move it like this. I can resize it. If I think that it is too big, I can change the size. I'm so sorry, my computer is not enjoying being with a share screen on Zoom and doing this. I can also rotate it. I can mirror it or, invert it, and do all the things that I could have done also when creating my model. This is just if you notice that you have a mistake, you don't have to go again to Tinkercad. Sometimes you can also correct it here. And then I can see some features here. For example, this is going to tell me the thickness of the wall, the thickness of the top and bottom. For example, the density will be 20%, which means that inside it will have air. Only 20% of it will be filament. I can make it more if I want it to be more resistant, or if I want something quicker, I can just make it less dense. And some very important part is the supports. My object doesn't need a support, but I'm going to try to see if I do not crash the program again, just to show you a simulation of needing a support. I will try it this way. I will try to rotate it. Like this, not less. Oh, okay. Let me see if it will generate, because now it is kind of flying, you see? I will test if it will produce supports. Okay, I asked it to produce the supports. And now if I create on slice, it will simulate the layers that the 3D printer will use. And we can preview. It is telling me already that it will take 43 minutes. It will use 4 grams of filament and 0.51 meters. And as you can see, it produced these supports here so that I don't have a problem when creating this keychain. Obviously, this is not efficient. The best way is to have it laying on the ground as I could with this particular object, and then I would not need supports. But just to tell you that if you have an object which has bridges or if it has angles, it is no problem. You can ask it to make supports. And now I can see the simulation. If I click on play, I can see the printer working. Oh, this is just the last layer. I can go and see how it will be printed. You see, it will print on all of these layers. Now I will have to have a little disk. I will click on Save to Disk. It will save on the little, either a USB, but usually they work with the small cards. I don't know, Gustavo, if you know the name in English, the SD cards. Yes, small SD cards. And then you put the SD card on the printer and you go to the media and you choose your printing. And the printers already have settings that you can say preheat for my type of filament, can be PLA, it can be PETG. This is a world. It is difficult for me to explain everything, but everything is online. I will just show you one more thing. If I go to Tinkercad again, this is a design that I made. I will now just delete it to start something different. I can also import designs, either an existing STL or even a vector. So for example, if I will bring Nucleo logo here, it will transform it into a 3D object. And now, for example, if I want, I could print it with 2, 3, 4 colors if I want. When the printer starts doing the first layers, I will stop it, change the filament, press play again with a different filament, and then stop, change filament, and I can do all the colors that I want. And you can find many different designs, 2D designs that you can bring here, and it will transform in 3D. But then you also have online libraries. So for example, we have Thingiverse, which is a very good one. It already has so many STL files already created. So if you need a very specific object and you don't have time to model it, you can just come here and find it. For example, if I would want an engine for some reason, I would see many different models already. Or if I want a cute astronaut, I can find many. I love this one, sitting on the moon. So I will click on it. And this will give me already the STL files ready to be printed. I will download all files. And I will definitely print this one because it is very cute. And I will save it. And now either I will open it with my Cura, Ultimaker Cura project program, or I can import it here and change size if I want, or change some specification of the design. You also have printables. It is also a very good repository of 3D models already made and tested. And you have the awesome ones by NASA. You have eclipses, you have the surface of some comets, you have satellites, the space station, and these are all already prepared, scientifically accurate, I think, because they're from NASA. And you can find a lot of educational printing stuff that you can use to teach geography, geology, mathematics, biology, and even languages. And also here on Tinkercad, going back to my main dashboard, you can find these menus here. So you have gallery, and in the gallery, you can find already made STL files, which you can then open. For example, this one, this little robot, I can copy and tinker. So if I do this, I can then change whatever I want, and I can export it to print it myself. And there are hundreds of things like this. You have projects which are written also for you to test with your students. Little cars, robots, keychains again, you can explore. And then on resources, you can find lesson plans. So these are challenges for lessons, and you can do it design, electronics, engineering, language and arts, mathematics, robotics, science, social studies, etc. And you also have the Learning Center. And in the Learning Center, you find tutorials that will teach you step by step how to start designing your own models with lots of different challenges. And they go from the simplest to the most complex ones. Again, the maker world is filled with people that are constantly sharing. So I bet you that anything you want, anything you need, if it's not online already, you will find somebody who will collaborate with you and will help you create what you want. And in this, I am including myself, my team as well. So I am sharing again my presentation. Now with the tips for the useful resources. Also, Google has everything, and ChatGPT can help you with many, many ideas of what to model to help your students learn more, or how to model something. And please save my contact. Also contact my colleagues, David. You met him on the last webinar, and we are always here to help. And I think that from my part, this is it. I don't know if there are questions, comments. We can wait a little bit if there are.
Thank you, Priscilla. There's
make
a
a comment,
second
Gustavo?
question. Yes, please.
Yeah, can you maybe share with the audience, because I know you have experience on that, how would you implement that to facilitate the learning of something with students? Can you tell them any example that you have of students that have been working with you, 3D printing their ideas, and how this was part of the curriculum or what they were learning at school?
Yes, I shared this in the presentation. I will share again just a second. So we have been working with lots of different maker competencies, not just with 3D printing. But for example here, if I can, okay. Do you see it? Oops.
Yes, we see.
So this one, for example, it's not the one that I was aiming to. I'm so sorry, my computer is very slow. Okay, so this one is a helix that was modeled and printed by the students. This one and also this one, they collaborated, the two groups, and they were making prototypes about sustainable energies and their importance, and they learned this in physics. and they made a little fair and they presented everything to the community. So they used electronics. They have a little motor here connected to batteries, of course, because we were inside, there was no wind. And they explain how this can work with the wind. Also here we have some the DNA helix, which is really cool. If we ask students to make the model and print, it's not that the teacher is printing and giving to the students. If we challenge students to model an accurate, scientifically accurate helix of the DNA, they will learn so much about DNA because they will have to learn it to be able to print it. Also here, this is a station that measures humidity and temperature of the air. And while learning to build it, students are challenged to do, okay, so how will you protect it? And they have to do something that allows air to come in and out and that fits everything. This was an intern student that we had that did this. These are some designs that are good for people that are visually impaired. It can enhance their learning through touch. We can have visual models of the solar system and the scales. In here, unfortunately, you can't even see the Earth because it's on the other side and I cannot change the picture. But it's a very, very powerful visual aid that we have when we show people and we say, where is Earth? And everybody starts to think it's one of these. And no, it's not. It's like 10 times smaller. Here, one of these little ones. And here, for example, this is a big example. They were building a solar car, but it could be a small car. It could be anything that they want to build in their classroom, but they were lacking these pieces. So instead of going out and buying some, they just made them. These are the most concrete examples I have here at my availability now. But students learn a lot of things. Even just learning how to model, they have to learn about dimensions, they have to learn about X, Y, and Z axes, they have to learn about mathematics by percentages, they can learn geography by doing maps.
Can I add something super curious as well? I know that, going to the moon is a challenging thing for humans, especially because you have to take everything with you, or you have to build everything there with what is there. And 3D printing is a very good resource because you take the machine with you, and then you have the raw material there to print your settlement, for instance. So I think 3D printing is a life-changing thing, and I wish I had that when I was in school. Don't you, Pri? That would be.
Of course. I love it. I think I would have had so much fun learning about it and learning through it.
Priscilla?
Yes.
We have a comment and a question on the chat. Ana Villar says it's fantastic that students can design their own models with a practical application. And so thanks, Anna, for the comment. I hope you have printers to play with your students. And Geoffrey has another question. He seems very interested. What types of filaments are there? And how do one chooses the best one for the model? So how do you choose among the many different types of filaments?
I'm going to be very honest and tell you how I choose. I ask ChatGPT or Google because all of them have different particularities, and I personally have a trouble memorizing. I know that you have PLA, which is an organic molecule, so it's not so harmful for the environment. It's one of the cheapest ones. And if you go to Amazon, for example, you have lots of colorful ones and very fun ones to use, and they're not so expensive. They're kind of cheap. You have PETG, which is the same material that we have on our water bottles, the ones that we buy. And there's actually a model that you can print yourself with PLA, for example, or PETG, which turns these bottles into filament. And so you can bring the bottles instead of throwing them away. you bring them to your makerspace or to your classroom or wherever you are. You create filaments through them, and then you can design everything through bottles that were once used. You have ABS, you have TPU, and many more. These are just the ones that I know from heart. Some of them are very resistant to physical damage. Others are very resistant to temperature, to humidity. Some of them you can then treat them to make a very smooth appearance, not PLA though, if you don't paint. So it depends on what you want to do. I suggest that before starting to do whatever you want to do, just Google or ask ChatGPT, I want to do this, which filament should I use? And then it can help you choose.
Good, thank you. So if you have any more questions to Priscilla, please put on the chat. This is your last call. There's another question by Jofer that's so cool. That is possible to create filaments with recycled material. So that's a very positive point. As usual, when it comes to practical things, seeking help online among the community of users is usually the best starting point. So of course you can ask ChatGPT or Google, but I suppose that maybe even in Tinkercad there's like a forum or a community that users can exchange experiences. And
there are many. If you are doing something that has already been done, I'm sure that you can find lots of people that said, I used this and it didn't work, so I changed this and it still didn't work, and then I changed that and then it worked. But if it's something new that someone didn't do, then you'll have to try.
On YouTube, maybe.
Mm-hmm.
Any videos, tutorials. So it's a really it's a world to explore, and the possibilities are really endless. Very well. Okay, so Rosa has shared a lot of links. Okay, so I put on the chat of the YouTube before we leave. So Priscilla, for the moment you have no questions, no comments. So if you want to make final considerations before we close the stream.
Yes. I want to make one final consideration. I think that every school should have more than 2 or 3 3D printers for their students to test. And also I would like to say that we do a lot of mistakes before we make one thing right. So don't give up. If you're a teacher, if you're a student, if you make a mistake, just laugh about it. Don't cry. I know sometimes it's very frustrating. We waste a lot of material, but it's part of the process. We have to fail a lot of times, especially in the maker movement. We fail and fail and fail and fail, and eventually we get something right, and it is very worth it. So just start it.
Excellent. Rosa, do you want to comment on the links that you shared?
Well, first of all, I'd like to thank Priscilla for the super presentation. I really think that this is the future. This is how children are learning, exploring the unknown. At least to me, this would be like completely unknown. And I think that's the way to promote deep learning and, you know, engage them in being creative and etc. I think, thank you very much. And you presented very useful things. And I love the fact that the makers out there are sharing things that they are doing so that others can use the ideas. So teachers, share what you've done or what you will do with your students so that others can also benefit. Thank you very much. I would like to say that we will be here until December 20 with webinars every week. Next week, we are going to have another exciting one with a visit to a place where they are constructing buildings, the spacesuit for the future people that are going to Mars or the moon. And you're going to have a sneak preview of what is it like to be inside of a lab that is building such a spacesuit, and how they test it to make sure that we can have humans alive on the moon or on Mars. I also would like to say that tomorrow, I don't remember the time by heart, I think it's 5 CET, we have our first Tea with Bits, which is a space where we just want people to get to know each other. Maybe Priscilla and the team at the Makerspace can come, and just Gustavo, Nikos, everyone can come to be there with the teachers. The idea is that just to have a space, have a tea together, exchange ideas, ask questions, talk about anything you want, get to know your colleagues from Learning from the Extremes. And we're going to have 3 of such events, and the first one is tomorrow. And if you are interested in participating, you have to register, otherwise you will not receive a link to come into the Zoom. This is not going to be a webinar mode, it's going to be an actual Zoom meeting. So register, come, share with your colleagues, tell them to join us in this common space. Another
It's at
thing,
5 CT, 5 CT.
5 CET. So it's 4
Yes.
o'clock for us there in Portugal, and it will be 5 CET for Central Europe, 6 CET for Greece. And we also are going to have from next week on 3 sessions devoted to the team in your schools that are writing proposals and willing to make partnership with other schools, or to provide you with mobility funding to go participate in courses like the one that we hosted in Marathon last year. So if you are interested, or your school headmaster or the team that write proposals in your school is interested to know how to do it, check the link about the Learning from the Extremes new partnerships, register, tell others, come and join us there. And last but not least, I'm also asking Gustavo to please share the link to the international conference that is going to take place in January in Athens, and also online, where we're inviting all Learning from the Extremes teachers to present the work that they have done, what they are doing with us in this project. And I guess that's it for announcements. I say goodbye to all of you. And I pass the microphone back to my colleague Nikos.
Thank you, Rosa. It is interesting that you have passed the microphone after saying all the information I wanted to say.
I'm always like that, Nikos.
Thank you, Priscilla, for this wonderful webinar. Thank you, Gustavo, for the support as always. Thank you, everyone, for being here. See you, if not tomorrow, next week with a very interesting webinar. And please make sure to check our websites and our social media for updates on our events. Thank you, everyone. Bye-bye.
Bye-bye.